Welcome to part 3 of the object-oriented programming lesson videos part thing. In this one, we're going to cover two things. One, we're going to go over overriding members, what that means. And two, we're going to just look at an example and make an actual project use object-oriented principles. So I have a game I've already created. I just made it. It's pretty great. You're going to like it. And then I'm going to show you there's a problem with this game that's an object-oriented approach would solve. And we're going to go ahead and make that change. And we're going to do all the code here in this video, and you will watch. There will be some editing. I'll try to keep it short, but I also want to show you everything, real example, real world style. In a somewhat contrived example, but you know what I mean. So here's my game. You are a wizard, and it's pretty great. You're a wizard and the orbs are falling and rocks are falling. I want this to be you skateboarding down a street. If you hit rocks, you lose some health. Every time you get an orb, you get some points. And then if you lose all your health, if you lose all your health, the game's over. So it's a pretty good game. Pretty good game. Got the wizard sprite, the rock sprite, the orb from opengameart.org. Credits will be in the description of the YouTube video for these art assets. Didn't make them myself. I messaged my sister. I was like, I need a drawing of a skateboarding wizard. And she's like, sure, I guess. But did not deliver. So can't trust family. Okay. So that's how it works. Let's see what all of our different parts are. The camera stays still. Doesn't do anything. All the items move instead of us moving the wizard and the camera. The wizard has a rigid body and a collider. We're not using this. I almost added a little walking animation, but I was like, nah. Anyway, it has a wizard script, a rigid body, and a collider. We'll come back to that wizard script in a second. The sidewalk are just the sort of edges here that stop the wizard from moving because we're using rigid body for movement. There is a thing called an item spawner, and it is set up with a minimum and maximum X and Y positions to randomly create the objects inside of. And it has things like the spawn interval. If we change that to 0.1, then an next we have my heads-up display. That's my thing. I have a slider over here, which has a value property. Changes the slider. And I have some text. Text has a UI score. Slider has a UI health bar. And that's very, very simple. So in the wizard script, we can see most of the code. These are all of our members. We have a class called wizard that extends mono behavior. And inside of it, it has a number of members. It has all sorts of fun stuff. It has the health and score variables. It has a Boolean for if it can move. It has its maximum health and its current health. It has the references to the rigid body, and it stores the velocity. Some other stuff. For my health, my score, my max health, I have created these sort of what we call getters, public functions that allow something else to read the value. Even though these are private and can't be accessed from anywhere else, these are public. That means there's a function here, an interface to look at what these values are by using this function, but there's no, what we call a setter. There's no function, there's no way for something else to change this value. So it's sort of a read-only property, basically. If we want to change it, we would have to call the gain points function or the lose health function. And these are nice because you can do things like check if you die. Right? Controlling not just making a public setter. We're using getters and setters, which are an actual thing. But having a function here where we take damage is like the correct place to check if our health has gone below 0. Instead of doing that like an update. Second move, we haven't gotten to that. I mean, it exists, it just doesn't do anything. In update, we change this velocity variable to be part of my input. And then in fixed update, we actually move depending on what that velocity variable is. So we move in fixed update, and we move using the rigid body's move position function, which is something that you maybe have never seen before. but it is basically it does all the collision checks. And then finally, here's like really where our code is. Here's the stuff we care about, is our on trigger enter. We check if the thing that we hit has a component called orb. And if it does, then we gain the number of points that is stored on that orb points. And here's the orb script. It's got a public integer for points. And then it moves us down and destroys itself on trigger. The rock has a public, is very similar. And you take note, it is very similar. There's some overlapping code, right? Orb and rock do the same thing. They both have a rigid body. They both set its speed to be negative. The rock, in this case, it has a damage integer and otherwise doesn't do anything. But we had to copy and paste this code. They share this functionality of moving according to some speed variable. And that's where we're going to make our object-oriented code. So that's the project. It's a very simple sort of infinite runner game. I don't think there's much else to explain about it. There are a number of problems with this current approach. And those problems are that for every time we add a new item, things would get difficult. Maybe I want to add an oil slick type item that prevents the player from moving left and right for a little bit. Maybe a little 360 animation. To do that, I would need to make that item and then do another check. Maybe like another if, else if, other dot. Right. Get component, blah, 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 blah. And then another item on top. I want to have a potion that you gain health with. And then another item to get more maximum health. And then another item to get extra super points or something. All of those, like after a while, I started adding features to my game. I have 5 or 6 items. This is going to get really difficult and annoying to maintain. And that's and all their code is going to have these copy and pasted values. So that's bad. So we don't want to do that. We don't want to do that. Instead, we want to create a base class that both orb and rock can inherit some behavior from. They can have their speed and their velocity be set in the base class. And then they will, as a child, just determine their own unique things, like having a damage or having points. You might think at this point you could just put it all in one class and give it points and damage and set them to 0 as appropriate, but that would be eventually you'd hit a point where that wouldn't work. It would have the same problems. You've just moved them from one script to another script, especially once you went to like trigger animations for the player, maybe store that data for like how you might flash the sprite or play the sounds, things like that. It would be cumbersome, wouldn't be very good. So let's replace this with an object-oriented approach. These extend from mono behavior. So let's make a new script that also extends from mono behavior that will be the new parent class for the orb, the rock, and any other obstacles that you could hit in this skateboarding game. So we have to come up with a name for them. Collectible, obstacle, something like that. We're going to go with obstacle. Obstacle. I feel like I said that right. Obstacle. And then we're going to move the speed property into obstacle. And also on our orb script, we're going to take this value, move that into obstacle. And then that is it for now. Let's go to and then this orb, here's the big part. The orb will no longer extend obstacle. Instead, extend mono behavior. Instead, it will extend obstacle, and obstacle extends mono behavior. So our obstacle has our private speed, has our velocity. We don't need update. Shouldn't define it. Siren going by. Let's do the same thing for rock. Let's take rock and change its colon here to obstacle, and we'll probably get some errors that we haven't hiding members, but just get rid of all that. There you go. So I think that was it. On our obstacle script, which I can, writer is telling me that 2 elements inherit from. I have my speed and I set it to move. Let's check my error messages. Okay, I had some errors. I thought I would. I no longer do. I finished editing the code. We're fine. Let's go to our prefabs and make sure we haven't lost our saved values. My speed here, my points value, my speed 6, my damage value. Great. And let's make sure it works. I still take damage. I still get points. Excellent. That hasn't solved the problem for the wizard script, however, because the wizard script is still checking for every single type of these child objects, and we don't want to do that. Instead, we are going to check if it has an obstacle, and then we'll call a function on that obstacle. What should we call this? Collide, collect, hit, bang, bing, bop, boop. Let's say collide. And it's giving me an error that doesn't exist. So let's go to our obstacle and let's make a collide function. And then we're going to get another error because cannot access private method collide here. On my obstacle, I need to make this function public. So I'll just have it spit out the name of the thing we collided with whenever we collide with it. And then we'll take this code and we'll comment it out so it doesn't do anything. We've broken the game. We're not getting points or losing health, but like, stay with me. Now we are calling this collide function on the parent class of the obstacles. So let's see if we are able to hit both orbs and rocks. Collided, you can see in my console. I am colliding with rock, colliding with orb, orb, rock, orb. Excellent. So that base class is getting called even though the things I'm hitting aren't obstacles, but they are orbs or coins. There is not a single obstacle object in my game. There are objects that inherit from obstacle in my game. So what I just said was a lie. There are obstacle objects in my game. The language is annoying and confusing, right? It is there, but it isn't there. It's like the whole point is we have these systems that can handle these kind of complexities where language fails us. Okay, so we have our obstacle and we can collide with it. So now we're calling this object on the base class, on the obstacle class, public void collide, but we need to call the object on that function on the child classes. But that function doesn't exist yet. And that's where we're going to introduce our brand new term. On our base class, we are doing things like setting our speed. I'm just going to call that speed there. And we have a collide function. And on our I have a transparency piece of paper here. We want to override this collide function, and then maybe extend it. So, but I want to write my own collide function. I want to write my collide function. Here's the problem. This deal, like, look at this, this is messy and confusing. There's 2 collide functions. Which one's the right one? Which one's the wrong one? What we want to do is override the base class with a function in the child class. So now my child class is this transparency piece, but there's this paper that's not transparent, and I am overriding that base function with the one on my child. We call this overriding. Okay. I feel like that went smoother in my head as a visual example. Would have been great. Okay. I'm on the wrong. Here we go. Hey, here we go. So, hello, I'm back. We have this collide function on the parent class, and we need to write the same function on the child class. But we're not done yet because we still have a problem. I'm getting an error that says the keyword new is required on collide because it hides the method void_obstacle.collide. We're not overwriting it quite yet. We're making a new version of it that is the same name. And that's sort of the default behavior in C# is it's going to keep that base class there, and it's going to keep our class here. They're going to have the same name, and depending on how you access the variable, it'll call which function. And it does this so that if you're using somebody else's code and you're using your code and you're extending things and things have the same name, by default, you won't break everything. But we don't want to do that. Instead, we want to add a very special keyword to our function. And that keyword is the word override. I am not just becoming another class with this name and then a really confusing and uncomfortable way to access it. No, I am replacing that function with my own. I am overriding it. And override, no suitable method for override, another error. Oh my gosh, I'm throwing you all errors. Well, that's why this isn't a follow along video. That's why you're just watching. Let's head to the obstacle class. We need to tell C#, hey, this function right here, this method, this member right here, it is okay for this to be overridden. By default, it's not okay. By default, you shouldn't do that, right? If I have, I can't just go overriding any class or function in the Unity engine and maybe having security concerns, I can't go overwrite my check if user is login function with my own function and then have it run my code instead of their code, that would be a security risk. So we need to be able to say when our code is allowed to be overridden by child classes. So we do that with the keyword virtual. It's not a great keyword. It's not super clear. Virtual. What is? We do so much stuff in virtual reality. We use the word virtual all the time to not mean yes, you can override this function. Sorry about that. That's just the way it is. It's a virtual function. It still exists right here. It does everything it needs to do, but it can now be overridden by the child object. Go back to the child. The error is gone. So on the child object, we can override a function on the base object, but we need to say, hello, I am trying to override this function. Hello, I am allowing you to override this function with our various keywords. And when those are all there, everything works. C# won't make any assumptions for you, and by default, it's making assumptions that are safe for publishing your code and having people and strangers work for it in secure conditions, right? Like security risks. So we want to make sure that we are nice and explicit because we're C# programmers. We have to type everything out. Okay, so we're virtual. And now we can override. So what does the orb do? Well, we get points. Okay. Get points. Let's put a comment there for now. Let's go do the same thing for the rock. I'm just going to copy this code. Copy. We'll go to the rock. And we'll save the image. So my wizard script. How are we gonna have the wizard either find the number of points, so we just have to know about the child, and we could do things like get component, or we could cast these to children and see if they are or not. And but then we'd be back to this big if-else chain. The solution is to move this logic of getting points or taking damage into this other object, into these collide functions. And to do that, we are going to go to the obstacle, and we're going to actually pass in our wizard. Right? We're going to pass in our wizard as a property. So on my rock, no suitable method to override. Well, that's because there's no such thing as a collide with no parameters. But there is a collide with one parameter of type wizard. And now we're good. Same thing for the orb. pass in the wizard. And now I have to put something here. I need the wizard to tell the obstacle that it collided with this, the keyword this, a reference to the object that is calling this function of this type, of this class. Not the game object, the class wizard. It's this, this. So I can tell the function that, hello, this is me, and you have collided with me. And now that the orb has a reference to the wizard that it collided with, it can do wizard.gain points, and it can do wizard.lose health. Just that property right there. And the reason we can call lose health in the rock, and the reason we can call gain points in the orb, is because these are public functions. Public void lose health, public void gain points. And we have implemented these in our wizard script. But we are calling them from our rock and our orb. But we can get rid of those comments and we can test our code. My code. I wrote it all. You didn't write any of this. Because you're just watching and paying attention. You're not trying to follow along. Oh. And now, the wizard takes damage. Great. Okay, let's add another child type item to collect and see how easy it is. What should we get health back? Should we gain health? Yeah, let's make a new C# script. We'll call it potion. Probably should call our classes things like health pickup and call our prefabs potion. The health pickup, just tells me what it does. And we will make it extend obstacle. Great. And then we will override our collide function. Look at all that code I just auto-generated thanks to Writer knowing how to do that. It also added this little line of code right here, which I don't actually want. But let's look at it. Base is another word for the parent class. Anywhere we type base, we're now referencing the parent class. It's calling the function that exists on the base class, calling this version of it. And then we can do our own code after that version of it. So if we leave that in here, or we even add that, here, and to the rock, passing in this variable along, now our debug messages would start spitting back out. They would all do the shared behavior, which is this debug.statement. And then after doing that function, it would do its own whatever. Okay. Where is that potion? Wizard dot get health. No, that's not giving you health. That's getting the health values. And that prefix get is universal, so we know that. What if we give like another? What if we just lost like negative values? No, we got to prevent you from going over the max. We'll write a gain health function on the wizard. Where's my lose health? We'll copy and paste this. Oh God, copy and paste. Oh. Health plus underscore health equals underscore health plus non-underscore health greater than or equal to max health, then I guess just greater than max health, then health equals max health. Okay. If our health is larger than our maximum health, our health should now become our maximum health and thus not be larger than it. Okay. Yeah, we'll gain our health there. And now our potion will give us health. Let's just do it right. Do it right. Okay. So now we need a new prefab for our potion. I'm going to duplicate the orb, call it potion, and we'll just make it like a green color, and we'll replace orb with potion. Set the speed to the same value. It'd be great if that was controlled somewhere else, but whatever. Health to gain 20, 50, yeah. And then lastly, on my item spawner, I have to add potion to the mix on my list that it's randomly choosing from. All right, let me lose some health and let me get it back. How easy was that? Cool. Broadly speaking, we still implement a lot of the wizard functionality, like controlling how the wizard gets its health on the wizard, because the wizard should be in charge of itself. But if I were to clean this code up a bit, I'd probably move movement into its own script. I'd probably make the speed of the items be set by something else. So I have a single property that changes them, so I can change that over time. The game can speed up. I would probably, what would I do? I don't know. I mean, this is like, for a simple game like this, like, it's not bad, right? I mean, setting the time scale to 0 is a really hacky way to pause the game, but like, whatever. But once you have these little gain health, lose health, like, functions all implemented in your wizard, you like don't need to rewrite that all over the place. And there might be lots of different things that give you health. You might set that, gain health. You might give yourself 100 health, like the beginning of a new level, you move around or something, etc. So to review our object-oriented stuff, we made a base function, and now the wizard doesn't need to check for all of the different types of things that can hit. It just checks to see for the one base class, and it calls that base functionality, and then the base functionality gets, depending on what object is actually the real one, the correct function will get called, because it is, these overriding members exist. So I hope that clears up some object-oriented stuff. There's more to get into, public, private. Now we can have things like protected, internal, more scope, things to go over. We'll cover that elsewhere. Okay, bye.